Meow, 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 meow. There's really only one data set that I'm offering you guys. It's this one right here, this Orthoimagery data download shapefile. So in GIS, one thing that I've been trying to find for you guys is the ability to get some high resolution ortho imagery, basically aerial photos of New Orleans that you can use as bases. I came across a resource that I think actually is better. And so this Orthoimagery data download shapefile, if you download it, extract it, and then bring it into your map, you can click on these tiles and it gives you a couple of links here to some high resolution ortho images that you can download directly to your computer. For this tutorial, you can see the tiles are just kind of like in these locations. I'm just going to download, say, that tile right there. So what you do is you click on that tile, and then you have several options here for the types of images that you can download here. The one that I think is going to be really nice is this one right here. Column here, it's called Y 2014 B03R01. It's just a code. This is aerial imagery from 2014. So it's a little bit old, but the huge benefit of this, I'm going to click on this link here. We're going to start downloading it, is that it is 3-inch resolution orthoimagery. What does that mean? It just means it's really, 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 really high res. They just finished there. So I call this like my 2014 3-inch orthoimagery. And this one here is 8719. And then it's in this one right here. If you don't see it in the list, just refresh that list. So it's right there, 8719. You bring that in. So there it is. And let's just zoom into it. And you can see like the quality of the aerial images is really, 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 really high. This is the fun part of getting this data, is just zooming into the map and just walking around, finding the solar panels and walking around the neighborhood, begin to actually understand what it looks like. Actually, maybe let's do one more thing. Click on that again. And there is one other data set that is maybe also worth considering. It's this one right here, Y 2017 B04. Let's download that. Okay, let's bring that one in. So let's take a look at these two together. A nice little technique you can use in GIS is to click on the raster layer on the top of two that you want to compare. As long as they're both turned on, you can go to raster layer and choose the swipe button right there. Choose that. It allows you to click and drag and swipe between two layers, so you can kind of like compare and contrast the two. The 2019 imagery you can see is much more recent. It's not as high res as the 2014 one. You can pick which one is more appropriate for your studio site. So two options for you. You can either go for the higher resolution 2014 imagery here, or you can go for the more recent one. So what I'm going to do now is we're going to take this image here and we're going to bring this into, I'm actually going to create an Infraworks model and show you that you can bring this image into your model and then actually have that as a high resolution base to the model. And then we're going to do a different technique of how to bring this into your Rhino model as well. Pick the general area, get your topopathymetry layer, right click on that guy, export raster, current display extent, give this a name, topopathy3.tiff. Export that out, open Infraworks, choose new, call this one NOLA Demo 5. Choose Work Local, choose the UTM-8415N, whatever data set that you use as, say, for instance, your model extents. Say, for instance, this one here, you can just right click on it, go to Properties, go to Source, and go to Spatial Reference there, and that tells you the coordinate system right there that is embedded within this system there. In Model Extents, we're going to define Model Extent, load extent from file, and we're going to choose, just pick that image that you downloaded as your extents and click OK. This in Infraworks, I'm going to turn off the contours. That's why you see all these little patterns here. And now we're going to add in the raster for the topo right there. So again, we're going to add that in, choose UTM-8415N for this particular coordinate system, close and refresh. We've brought in the topo data with no reduction in resolution. Now let's bring in the aerial. So go to the data sources, choose raster here, and it's this one right there. It comes in as ground imagery, then double click on that. In coordinate system, choose that UTM-8415N. Make sure the type is set to ground imagery, and then choose close and refresh. We have created a high resolution model with high resolution topographic data and high resolution aerial imagery, you're 50% of the way there to, say, for instance, creating an aerial view or an aerial image. Take advantage of this. So what we're going to do is, in order to bring this image into Rhino, we need to have some kind of way to reference it to, say, for instance, a shapefile, so that when we bring the image in, we can know how big it is and what scale it is. What we're going to do is we're going to select the Orthoimagery data download square and then export that to CAD. In geoprocessing, we'll go to export to CAD. And then in input features here, we're going to bring in that Orthoimagery data download feature. Whenever you export stuff to CAD, if you have something selected, like I do right now, it will only export the selected thing to CAD. An output file, I'll just save it to my desktop box, CAD, yeah. And then in environments, I'm going to set the output coordinate system to be the current map, because my current map is set to the NAD 1983 State Plain, Louisiana South feet system. Then choose run. So now we're going to open Rhino. In Rhino, every time I open Rhino, I always just check units. So I type in units, make sure that the units that the model is in this case feet, will match the units of whatever I import. And now we're going to import that CAD layer, box CAD, make sure it's set to feet as the model units, then click OK. And then just choose the zoom selected button that zooms to that square. So what we basically do is if we just bring in the TIFF and we just make sure that it matches the rotation, the extents of this square here, and that's it. But what I recommend doing first before you do that is to go into Photoshop, go to the image that we want to bring in, and we're going to bring in this one right here. The reason we want to do one quick thing is because you can see this image here is 849 megabytes, and we just want to make the image a little bit smaller. Also, this is an opportunity for you just to like touch it up a bit. So if you want to say, for instance, go in here, do an auto color and maybe make it brighter. And then, once it looks good to you, just go to File, Save As a JPEG. I actually, for this particular type of workflow, I actually make sure that this slider is set to like 2. So just choose OK. This file that we've saved now is 27 megabytes. So we've significantly reduced the file size of it. So now we can go in here. I'm going to put the image on the Orthoimagery data download layer. I'm going to use in the surface tools here. There is this picture plane tool right there. That's the tool. So I click on that. And then we're going to choose the one we just created, which is this. Click open. And then I'm going to choose this option here called 3-point. And then it's going to ask for start of edge. I'm going to click on the lower left. Then choose the lower right, and then choose the upper right. So now you've brought in the image. Now you can go back into GIS, and now let's say you want to export roads, tax parcels. Go back to the export to CAD. It's still already open. Now we're going to choose edge of pavement, tax parcels, add those. And the export file, we'll call this one maybe add export. Because this data is not clipped, you want to make sure that in processing extent here, you set that to be current display extent. So now we choose run. And now go back to Rhino, type in import, go to that right there, type in open, okay. And hopefully you see that everything is aligned correctly. Okay, you have stuff in Rhino now, but maybe you want to bring stuff back into GIS. And so I'm going to create a new layer in here and call this one LSP. And then we're going to start drawing stuff. So basically what we're going to do is we're going to use this tool to begin to draw. I'm going to draw the pickleball court. And the point is basically you might have a feature in your model that is not vectorized yet, but you would like to have it be vectorized because you want to use it as part of your base model. So you've drawn the pickleball court there. You select it, right click on the layer that the information is on, then choose select objects, file, export selected. So I'm going to save it into this folder here, and I'm going to save it as a CAD file. And we'll call this one Lower 9th Ward SP. Save. Choose this one as your export scheme, 2007 natural. So I click OK. And now go back into GIS and now go to your catalog. It should be in here somewhere. So yeah, right there. Lower 9th Ward SP.dwg is right there. If you expand that, you get points, polygons, and polylines. Really the main thing is that's most important is this one here, polyline. So I'll bring this in. And now you can see right there, those are your the line work. Oh, I forgot to draw this thing here. All right, hang on. Go back in here. Okay, now I'm good. Right click, select objects, export selected. I'm going to save over that lower ninth word SP thing there. Replace, yes. You okay? Go back to GIS. Oh, it just shows up. It just shows up. Oh, wait, I forgot to draw that thing there. Go back to Rhino. Let's put some circles to represent the thing there, that thing there. Oh, right click, select objects, export selected, save over that. Yes, okay. There it is. Okay. All right. I was being a little bit sarcastic there, but my point is this. That's what the whole point is, that you go back and forth seamlessly and quick. That's geospatial modeling, is that you need to be able to be nimble between both scales of work, the mapping scale here, and then your modeling scale here. So I'm going to go back to GIS and we're going to turn on the topobathymetry layer again. I'm going to show you a technique, and that's how to take the DEM here and cut section lines. What we're going to do is you have your DEM here, and actually it doesn't have to be a DEM. It can actually also be the DSM as well, this data set right here, if you want. So what you do is you go to your site, and what we're going to do is we're going to create a new shapefile. So in my catalog, I'm going to go to my data folder. In this case, it's going to be this one right here. I'm going to right click on the folder and then choose new shapefile. So I'm going to create a new shapefile. I'm going to call this section cut. In geometry type, we're going to choose polyline. And then in coordinate system, we're just going to choose current map. Then choose run. And you see it brings in that newly created shapefile into your contents on the side there. I'm going to change the symbology to be a red line, 2-point width, hit apply. So now we're going to draw some lines across our, in this case, this site here. So with that section cut selected, I'm going to go to edit, create. I'm going to choose that section cut line as the layer that you want to create stuff in. It's going to ask you to create a line right there, and then you just draw a line. So I'm just click somewhere on the map, then I'm going to click somewhere else, double click to close. Let's do a few lines of different types. Maybe it's cut through the canal. So I'm just going to draw a bunch of lines. And then once you have your lines drawn, hit save. Save all edits. Yes. Make sure you don't have any line accidentally selected. And then what we're going to do is we're going to go to a tool in our geoprocessing called Interpolate Shape. So it's in the 3D Analyst tools, Interpolate Shape. Choose that. In the input surface, that's going to be the topobathymetry layer. Input features, this is going to be that section cut. Then in output feature class, it's just going to save this into your geodatabase. So I'm just going to select that name there. I'm going to call this one section cut 3D. And then in Z factor right here, you need to put in the conversion number from meters to feet. So that is 3.28084. Then choose run. Okay, so you see now you have a new shapefile here. It's kind of hard to see because it's in pink, but it's there. So now this, you can just use the export to CAD tool again. So let's do that. So go back to geoprocessing, export to CAD, input features. We're going to bring in the section cut 3D and output file here. We're going to save it to our desktop and we'll call this one sections. And then in environments, make sure that's set to current map. Then hit run. Now in Rhino, it's going to zoom out a bit. I'm going to type in import sections, make sure the model units are in feet. So hopefully you see the section lines, they're not very dramatic because of the very subtle topo change at a regional scale. But even here, you can begin to see the topo of the river. So this is the easiest way to cut sections at a large regional scale. You can scale them. So with those selected, and if you have the gumball tool visible here, it's easy to scale them in the Z direction by clicking on that little blue square thing here, right there in the gumball, and scale it by like five times, 500%. And then that begins to make the section a little bit more dramatic. So that's how you cut section lines. Any questions? What I want to do next, review cutting contours one more time. Let's go back to this site here again that we've been using as this demo. And the contours are always cut from the topobathymetry layer. And I'm going to show you two techniques. One's just cutting straight from this layer here, but another one is to use a special tool called Focal Statistics to simplify the output visual. So here's how that works. So contour is in geoprocessing, so type in contour, and that's the first tool here. Input raster, we're going to choose the topobathymetry layer. Output feature class, I'll just leave it as is. Contour interval, we'll call that, we'll do 1 for 1 foot. And again, because we need to convert meters to feet, we put 3.28084 in the Z factor. And then in environments, make sure that the extent is set to the current display extent, then choose run. So one thing you notice here is that this provides you really, really nicely detailed contours. But a minor issue with this is that it's too detailed, especially in these areas here where the topography is very subtle. There's a lot of these really small little, you can call them like island contours that actually do not provide any significant, meaningful information whenever you're doing grading or stuff like that. So there is a tool called Focal Statistics. And what that does is it takes the raster image and it looks at each pixel and it kind of compares it to its neighboring pixels and then averages them out. And what it does is it kind of smooths over a lot of those small little areas where there might be bumps and dips. So in geoprocessing, I'm going to type in Focal Statistics, and that's right there. Focal Statistics Spatial Analyst Tools right there. So it's actually the second one in this particular list. So in input raster, we're going to choose the topo bathymetry layer. In output raster, let's save it into a folder. Call this one topo bath. I like to put FS whenever I do focal statistics on something, and then .tiff. And then in environments, we're going to do processing extent, current display extent, and then choose run. And what we've created now is we just created a little section of that, raster, but it's been smoothed out. Now we're going to do the contour tool again. So we now go back, contour, input raster. Now this is going to be topo bath FS. Contour interval will be 1. Z factor will be 3.28084. Environments, we're going to now set this to current map. In extent, we're going to use current display extent, then choose run. So let's compare the two results. Let me make the ones that came from focal statistics blue, and let's make the other ones already red, and the simplified versions on top. And you can see already the blue layer has kind of smoothed out and also removed a lot of the small little bumps and depressions. One thing I always do is, even with focal statistics, you still have some little circles and islands and small little contours there. So it's at this point, it's just deleting those. So what I do is I go to the attribute table for the contour layer, and then I sort the contours by its length. So I click on the length column, then sort it from A to Z, sort from small to high. And then basically what I do is I select the first line, and then I kind of scroll through this list here, and you can decide what is the cutoff point to delete. Let's start with like from 0 to 50. So when it gets to the 50 length here, so I hold shift and select all the contours up to like 50-ish. And you see that the contours that are selected are all those really small, tiny little contours that don't really help you in any meaningful way. So we're going to delete these. So I'm going to choose the delete selection in this attribute table button there. So choose that. And now you've cleaned up that data set significantly. And then make sure you hit save in the edit tab. Whenever you change a data set, you need to save it. So choose save there. Yes. Now we're going to bring this into Rhino. So in order to bring it into Rhino, but have the contours come in with the elevation associated with each line, you need to add a field in the attribute table. So with the attribute table open, I choose add field right there, and it brings up the field editor there. In field name, call this one elevation, and then data type, choose double, and then hit save. And you see in the attribute table now you created a new field called elevation. I'm going to close the field editor right there, close that, so you're back to the map. And then in elevation, select that column, right click on it, choose calculate field, and brings up the field calculator. In elevation, where it says elevation equals, just set that to be equal to contour. Then choose OK. What it basically does is it takes the number in the contour column and it copies it to the elevation column. And the reason this is important is because any data set or any piece of data that has an elevation attribute, that elevation attribute is read by CAD and actually sets it to the correct Z elevation. So then with that all set up, now we just go back to export to CAD. So go back to geoprocessing, export to CAD. Input features, we'll choose that contour topo bath, and output file, we'll just save this as contours topo bath. And then environments, we'll choose the current map as the coordinate system. And in processing extent, you can set that to be current display extent, but it doesn't really matter because in this case, we know that the data set is just that. So now we'll click run. And now go back to Rhino, import, contours. Let me turn off that there. And these contours are in 3D as well. So if I zoom into it, you should see, yeah, there's some elevation in there. It's just very subtle because it's not very dramatic elevation. So I'm going to show you my Grasshopper script. Let me do this. Let me really quickly, before we show you the script, I just want to pick a different area that's a little bit more dramatic, just so that what I'm going to do is I'm going to pick an area like here, focal statistics, imagery, it's fine, extend, current display, extend, run. So now we got a little section here, then we'll got contours, that guy, contour V1, Z factor 3.2804, environments, that's good, run, do that, right click, attribute table, add field, elevation, bubble, save, you're not there, going here, sort, doing everything in real time now. Select things by length, delete everything that's up to like this number here, 80, delete, edit, save, yes, elevation, field calculator, elevation equals contour, okay, geo processing, export to CAD, this guy, going here, contour, grasshopper, demo, environments, same as the current map, parameters, run, so Rhino, import. All right, I just want to get to this point here. I wanted something a little bit more dramatic. When you have contours that you've successfully exported into Rhino, the question always comes up, I want this to be a solid surface. What you need to do is you need to go to a plan view first, and you need to create a layer called B-box, a bounding box layer. And I'm going to create a layer called bounding box and make it red, set that to be the current layer. And I'm going to choose the 3-point rectangle tool, and I'm going to turn off my snapping for now. And what we're going to do is we're going to draw a box that kind of fits within those contours. You see how the box here, if I zoom into it, it's not going outside of the contours, it's staying within them at all times. It has to do that everywhere on each edge. Then we're going to open Grasshopper. And so in box, there is a script in there. It's called Frank's Mesh to Surface, I believe. You can see I have a Grasshopper folder. I have all these Grasshopper scripts I've written over the course of my career. It's actually kind of sad, I gotta say. Frank's Mesh to Surf annotated. Open that, okay? And so this is the script. So everything is already written for you. You just need to follow my steps. What I recommend doing, whenever you work within Grasshopper, you wanna make sure that you disable certain parameters and buttons that exist later in the script so that you don't crash the script accidentally, especially when things come together. So the way you do that is you basically drag and select buttons like that. And then you click on the middle, hopefully you can see my mouse here. You click on the middle mouse button on your mouse anywhere within the environment, and it brings up this little wheel here. And then you just choose this thing called disable. Now these don't work. We're going to turn them on in a minute. Okay. What we're going to do is in this first section right here, input your contour curves. This here, you right click on this guy, choose set multiple curves. And then we're going to select all the contours here. So I'm going to right click on that, select objects, and enter on my keyboard. Give this about a minute. It worked. So it just took about 5 minutes, but it worked. Now we're back in business. And what I'm going to show you now is, let me make this a bit smaller of a window. Let's move this over a bit here. If you go into this right here, mesh right there, click on that, then again, middle mouse button, then choose this enable preview. This is that mesh that we just created. We took all the contours there and we exploded it into vertices, and then we meshed them together. You can see that it's created this mesh of the surface. This is very similar to, what you would expect to see, say, for instance, in Infraworks, very detailed. The mesh is not the output that we want. We want to create a surface. What we're going to do is we're going to convert this mesh into a surface, and this part will not take as long. Also, this is where I want to just, again, go back to the whole rectangle thing. This rectangle here needs to be inside of the mesh. In Grasshopper, now what we do is in this upper portion here, we'll right click on this curve there, set one curve, choose that curve there. And then it's going to take that. Let me actually go down here, hide the mesh temporarily so we can disable preview. This is my favorite thing about Grasshopper. Disable preview is a blindfolded hostage. So disable preview. Actually, this is one thing we have to do first is we have to take I should have done this earlier, take that box there and we need to move it below the contours like that. Okay, so then in the top view here, you see what we've done is basically what this upper portion here does is it takes that surface and it divides it into a grid of points using this surface divide tool here. And so you can customize the density of this grid here, if I zoom into it, just by moving these little sliders here. So if I move it backwards, it reduces the density of it. If you move it to the right, it increases the density. And so your goal here is to just basically kind of customize this a little bit until you get what appears to be a fairly consistent, even grid of points. Now, the more points you have, the more detailed the final result will be. And then what we're going to do, select those guys there, hide the preview, click on the blindfolded hostage to hide the preview. And now we're going to do the last 3 things. So I'm going to go back here, select these things here, hit the middle mouse button. Now we're going to choose this enable button. So I'm going to click on it. And when it finishes, it actually won't take that long. So that is the end result right there. If I turn on preview, this is what we get. It looks very similar to the previous thing there, but this is now a surface. So now what we do, create a new layer in Rhino, type in surface, set that to be the current layer, choose that, hit your middle mouse button, then choose the egg icon, which is the bake, choose that. And now what you do in Grasshopper, you choose this little button here. Don't draw any preview geometry right there. That hides everything in the window here. So now we just get out of here. In 3D, now you've created a surface. If we go to like a shaded view, you should be able to see that end result there. That's a surface. Unfortunately, Mimi is in my bedroom all the way over there, so I can't take her out for a cameo. So today is going to be a sad day because there's no Mimi to show you guys. Sorry. Goodbye.